Good morning, everyone. This is Mr. Shields back again with another video. Today, we're going to be adding and subtracting radicals. So we're really building on a topic that we covered last week here. So this topic shouldn't be new to any of you guys. We're actually just going to be reviewing an old topic that you're actually going to be using next year, whether or not you're in geometry or algebra 2. So I think you're going to find this skill very useful. So that's why we're going back over this topic once again. So we're going to need our perfect squares, and I have them listed here on my note card. So feel free to jot those down on your paper. You're probably going to need these because the steps to doing this are pretty familiar to us. Step one, we're going to simplify all radicals. So we have our very first example here, -2 square root of 20 minus 2 square root of 5. So I'm going to look to see if there's something that I can reduce. And if I look at my two radicals here, I believe that 20 underneath that sign can be broken apart. Now, if I look over here to the right, that 5 looks like it's pretty good. There's really nothing much I need to do with that. I can actually bring that down straight away. So I'm going to bring down the 2 square root of 5. So I'm good to go on that end. But I still need to go ahead and deal with that term that's on the left-hand side, that 20, which can be broken down a little bit further. So like we did last week, we're going to find the biggest perfect square that can go under, or that can go into that number under the radical sign. So in this case, looking at my list here, I believe 4 is going to be the one that we're going to be using here today. So I'm going to have 4 as my perfect square. I'm going to bring down that -2 because we're going to have to do something with that. And then once I've taken my 20 divided by 4, I'm going to get my 5 on the right-hand side here. Then I'm going to go about the process of trying to simplify this. So square root of 4 is just 2. And we're going to take that and multiply that by the number that was outside of the radical sign. So -2 times 2 is going to give me a -4. And then I can just bring down my square root of 5. Now, what you should notice is that under the radical sign, we have the same number. And that's one of our big goals. We want to have that same number under the radical sign because that means we can go about the process of adding and subtracting. What are we going to add and subtract? Well, the numbers on the outside here. So I have a -4 minus 2, which is going to give me a -6 square root of 5. So just to recap what we did, we checked to see if we could simplify any of the radicals that we had. In this case, we were able to simplify the one on the left. Once we simplified both of them and we had the same number under the radical sign, then we could actually go ahead and subtract the -4 on the outside from the -2 also on the outside of the other radical sign, getting us a -6. The number on the inside of the radical is actually going to stay the same. So we're good to go there. So let's get into some more examples here. And the first two are actually really easy. If you'll notice number 1 here, do we need to simplify? Well, doesn't seem like any other perfect square other than 1 can go into 6. So it looks like we're good to go there. And they're both the same sign under the radical sign. So I can go about the process of subtracting my outside numbers here. So 3 minus 2 is just going to give me a 1 square root of 6. Now, another way of writing it, the way that you'll most commonly see this written, is just the square root of 6 without the 1 there. It's kind of understood. Number 2 is also, I think, pretty straightforward. Step 1 is pretty much done for us. There's nothing really that we can go ahead and reduce. So we have the same number under the radical sign. So that's a good indicator. So we'll be keeping that. And we can go ahead and add the 2 numbers outside of the radical sign. So 2 plus 2 will just give me 4. And 4 square root of 5 is going to be my final answer. Now, will our other problems be as straightforward as 1 and 2? Well, you can probably already guess, no, that's probably not going to be the case. So if we look at number 3, we're looking first to see if we can simplify anything. So if I look at 10 square root of 7, looks pretty good. I don't think any other perfect square can go into that other than 1. So we can just bring that all the way down here, 10 square root of 7. So that one's already ready to be added. But what about the term over here? That we can break down. That 63 can be broken down a little bit further here. So what's my biggest perfect square that can go into 63 cleanly? Well, you might have guessed it's actually going to be 9 here. Okay. Put my little 2 out here because I got to bring the 2 down. And so when I do 63 divided by 9, I'm going to end up with a 7. Okay. And then I have to take the square root of my perfect square, 9. And so the square root of 9 is just 3. I'm going to write this over here so I have a little bit more room here. So I have the 3, but I'm still going to have that 2 on the outside. Square root of 7, if we were to break that down, that would just be a decimal, so we don't need to do that. And so when I have 2 times 3, I'm just going to end up with a 6. And that square root of 7 is going to stay there. And what you should notice is that I have now the same numbers under the sign. And so when I do that, I can go ahead about the process of either adding or subtracting. In this case, we're going to be adding. So 10 plus 6 will give me 16. And then I'll have the square root of 7 as my final answer. Okay. Looking over at number 4 here. I have to check to see if there's something that I can simplify. If I take a look at my first term, the square root of 15, that looks pretty good. Doesn't seem like there are any perfect squares that can go into that. So that is actually really good to go. So we can just bring that straight on down. So I'll draw my arrow. But as you probably guessed, that 6 square root of 60, that can be broken down a little bit further. So let me just rewrite that over here so I have a little bit of space here. And so once again, as we did on the previous problem, we're going to look to try to find the biggest perfect square that can go into 60. And strangely enough, the biggest perfect square that can go into 60 is going to be the square root of 4. Okay, square root of 4. Now I'm still going to have that negative 6 on the outside. I'll have to deal with that at some point. And then when I take 60 divided by 4, I'm going to end up with 15 under that radical sign. Okay. Now, I can simplify this a little bit further here. So the square root of 4 is just going to be a 2. And I'm going to take that 2 and then, of course, times it by the negative 6 that's on the outside, leaving me with a negative 12. I can also bring that down over here, square root of 15. So now I have simplified the term on the right side. I can bring down this term over here, the square root of 15, which is a little bit further away. So I'm just going to go ahead and write that over here again so that they're a little bit closer to each other, just so it looks a little bit better. Okay, so I'm going to have square root of 15 here. Give myself a little bit of space here. Now, I can go ahead and actually simplify those. I have the square root of 15 minus 12 square root of 15. Now, something I want to point out to you, just like we mentioned in number 1, I don't have to write the 1 on the outside. It's understood. So there's that imaginary 1 that's going to be in front of the square root of 15. So I'm going to have 1 minus 12, which is going to end up with a negative 11 square root of 15. So once again, we're simplifying what needs to be simplified. In this case, the left side was really good, so we brought down the square root of 15. On the right side, though, we had to break down that 60 here. So we had the biggest perfect square being 4. Multiplied, once we took out the square root of 4, which was 2. 2 times negative 6 gave me a negative 12. And then that square root of 15 stayed the same. And then all we had to do was actually subtract what was on the outside, that imaginary 1 minus 12, which gave me a negative 11, okay? Let me just highlight those numbers on the inside, because before you can add or subtract, you need to make sure that you have the same numbers on the inside of the radical sign. All right, so let's take a look at number 5 here. So we have an example whereby we actually have two things that are going to have to get broken down. The previous problems, we only had to deal with one. Now we're going to actually have to deal with two, which can make things a little bit more tricky, but I think we'll manage it all the same. So I know that I'm going to have to break down 32. Already know that. So I'm going to go put a little demarcation line here, because I'm going to have to break down the 2 square root of 32, and I'm going to have to break down minus 3 square root of 18. So I'm going to look for the biggest perfect square that can go into 32 just to start the ball rolling here. So I'll put my radical signs, I'll put radical sign here. And my biggest perfect square I found is going to be 16. So 16 is going to be that big perfect square that can go in there. And so 32 divided by 16 is just 2. Now, I don't want to forget about the 2 that's on the outside. That's going to be very, very important here. So we're going to have to bring that down, because that's going to contribute to our final answer here. And so when I go ahead and take the square root of 16, I'm going to end up with 4. But I have to account for that 2. So that has to get brought down. I'm going to multiply on the outside 2 times 4, which is going to give me an 8. So once I've simplified this left-hand term, I'm going to be left with 8 square root of 2. Now, I'm going to have to go ahead and simplify the other side here. And I'm just going to write this over here so I can have some space. You can tell, kind of getting, trying to get all those things in those boxes sometimes can be a little bit tricky here. So you always make sure you have plenty of room, but you guys are using scratch paper, so you should be good to go as far as spacing is concerned. So once again, with my little square card, want to find my biggest perfect square that can go into 18. And that lucky number just happens to be 9. And so once I've done that, I'm just going to break it apart like we've been doing here. So I'll have a 9 here. And then 18 divided by 9 is just 2. And then I can bring down my negative 3. Once I take the square root of 9, we're going to end up with a 3 here. And I'm going to multiply that by the negative 3 that's already on the outside. And so once I do that, negative 3 times 3 is going to give me a negative 9 that I can bring down, or that minus 9, square root of 2. And what you should notice is that, hey, I now have the same number under the radical sign. So now that I have both numbers being the same, I can go about the process of either adding or subtracting. In this case, we're going to subtract 8 minus 9, which is going to give me a negative 1 square root of 2. Or you could write it as such. You could just have negative square root of 2. Either or is going to be good for me, but the second way is probably going to be the more common way that you're going to see it written out. So get used to it that way.